If space were filled with air, the implications would reshape our understanding of the universe and the very nature of space travel, astronomy, and physics. Here are the potential consequences and considerations in such a scenario. Space travel. Complexity. Current spacecraft are designed for a vacuum, where they encounter minimal resistance. In a universe filled with air, space travel would resemble atmospheric flight, requiring spacecraft to be aerodynamic and robust enough to withstand air resistance and the heat generated from friction. Rockets would have wings. Rockets would need significantly more fuel to achieve the same speeds and distances, making space travel more complex and costly. Satellites would need constant propulsion to stay in orbit, as atmospheric drag would cause them to slow down and fall back to Earth. This would make maintaining satellite networks for communication and GPS far more complex and resource-intensive. Breathing in. Space. The presence of air might imply that astronauts could breathe in space, eliminating the need for spacesuits and life support systems. However, if the air's composition and pressure were not suitable for human survival, or if temperatures were extreme due to solar radiation heating the air, protective measures would still be necessary. Thermal dynamics. Space filled with air would have vastly different thermal dynamics. Heat from stars would warm the surrounding air, potentially leading to extreme temperatures across the universe. This could create a range of environments from scorchingly hot near stars to bitterly cold in areas far from stellar heat sources, affecting the habitability of planets and the feasibility of space exploration. Sound propagation. Unlike the current vacuum of space, air would allow sound to travel. This means that the noises of cosmic events such as supernovae or colliding asteroids could be audible. This would not only change the experience of space, but could also provide new data for astronomers to study celestial events. Astronauts on spacewalks might hear the hum of their spacecraft, the whirring of satellites, or even the sounds of solar storms and cosmic events. Altered physics. The fundamental laws of motion and energy would behave differently in a universe filled with air. Spacecraft and objects would lose momentum due to air resistance, and the propagation of electromagnetic waves would be affected, potentially altering how we observe and measure cosmic phenomena. Astronomical observations. The clarity of observations made from within an air-filled space would decrease due to the scattering of light by air particles. This would complicate astronomical research and observation, making it harder to study distant stars, galaxies, and other celestial bodies without the clear view we currently have from Earth and space telescopes. Telescopes would struggle to get clear images due to the scattering of light by the air. Stars and galaxies would appear blurry, and many of the deep space discoveries we've made would be impossible with our current technology. Cosmic radiation shielding. While air could offer some protection against cosmic radiation compared to the vacuum of space, its effectiveness would depend on the air's density and composition. This might not suffice to protect humans and the electronic equipment from the high-energy particles prevalent in space. Orbital mechanics. The presence of air would also affect the orbit of celestial bodies. Planets, asteroids, and comets would experience drag as they moved through space, potentially leading to orbital decay and altering the dynamics of solar systems and galaxies. With air resistance slowing down space debris, Earth might experience more frequent but less intense meteor showers as objects in space burn up in the denser atmosphere at higher altitudes. Evolution of stars and galaxies. The life cycles of stars might be different in a universe filled with air. The processes of star formation, supernovae explosions, and black hole formation would be influenced by the interaction with the surrounding air, possibly leading to different types of astronomical structures and phenomena. Living and working in space would be different in such a universe. The experience of walking on a planet without a spacesuit and hearing the sounds of space would be profound. However, the challenges of dealing with the dynamic and potentially hostile environments created by air and space would necessitate new strategies and technologies for exploration and habitation. In conclusion, an air-filled universe would present a radically different reality from what we know today. The physics of movement, the nature of space exploration, the methods of astronomical observation, and even the sounds and sights of space would be transformed. The challenges would be immense, but the opportunities for discovery and understanding would be equally vast.
Wow, the great day is finally upon us. The record-breaking hole-boring team is finishing their job today. Spectators have gathered from all parts of the continent just to look at the greatest borehole in the world. And even the Guinness World Records Commission is officially dumbfounded. The hole is more than 1,000 miles in diameter and goes almost as deep as the Earth's core. No one achieved this depth before. But wait, what's going on? People all around suddenly begin fainting. More and more of the spectators fall unconscious on the ground, their faces white. Did the diggers hit some dangerous gas pocket? Oh no! We're getting messages from all over the world that people start falling just where they stood. What in the world is happening? So, this is the scenario you get if you dig a hole in the ground deep and wide enough to fit the whole atmosphere inside it. Let's explore. The atmosphere goes really high up, getting thinner and thinner the higher you rise. For example, on the ground level, you can breathe freely, while on top of Everest, you won't be able to survive for long if you haven't had a good training course beforehand. The air on the mountaintops is much thinner, and so it's a lot colder and harder to breathe there. If you rise even higher, say to the altitude where airplanes fly, you probably won't be able to breathe at all. That's because they have oxygen masks on board. If the plane loses its inner pressure, the air from the outside will rush in. And since it's too low in oxygen for your lungs, you're likely to lose consciousness very quickly. All that doesn't mean our atmosphere ends there. In fact, it goes far beyond. And some scientists say it could even include all the distance to the moon and even further. Oxygen molecules from the Earth's atmosphere can be found at massive distances. Although there are so few of them, you won't be able to use them anyway. And the furthest range the atmosphere goes is almost twice as far as the moon. But those are no more than tiny specks of hydrogen at that point. Now, if we somehow compress all this volume into a relatively small bubble around the planet, it would be about 6 miles above the ground, roughly the height at which commercial airplanes fly. Any higher, and there's big cosmic nothing called vacuum, where no airplane would be able to navigate. Next step, fitting this mass of air into a hole in the ground. For starters, the entire volume of our rather thin bubble is only enough to fit into a 1,000-mile cube. This is just a little smaller than the Earth's core, and a side of such cube is about 1/3 of the United States east to west. And here's the first serious problem. No one has ever dug a hole that deep, or wide for that matter. The deepest human-made hole in the world is the Kola Super Deep Borehole, and it's only going about 7 miles down. The drilling stopped because of unexpectedly high temperatures. Drilling and digging, though, are different things. The Kola borehole is only 9 inches in diameter, while what we need is to take a supermassive chunk out of the Earth to fill it with air. Still, at about the same depth, we'll face the temperatures of around 350 degrees Fahrenheit, and the deeper we go, the hotter it'll get. The Earth's core lies at 1,800 miles, so to dig that cube, we'll need to go more than halfway to the center of the planet, where the temperature will reach almost that of the Sun's surface. And that's not considering the time we'll need to dig that deep. Anyway, let's assume we have the equipment that can withstand such heat. As we go down, the air fills the pit and slowly leaves the atmosphere. And as it gets deeper, the pressure on it grows too, making it take less space. In the end, with all that weight from above, we won't even need such a deep hole, right? Nope. The high temperatures in the Earth's innards makes the air less condensed and compensate for the pressure. If the surrounding rock is hot enough, it will expand the air to such a degree where it will take the same amount of space as on the ground level. And when it gets even hotter than that, well, the air will actually take even more room than we've calculated. But we diggers aren't that easily daunted. The experiment continues with an actual 1,000-mile cube dug in the Earth's surface, reaching into the crust and mantle and almost to the molten core. The air expands from the heat and starts taking up more space, resisting its imprisonment. That's why we begin digging to the sides at lower parts of our hole. To compensate for the air expansion, the additional hollows span over 4,000 miles. That's about the radius of the planet. Finally, the air seeps down, leaving the atmosphere and filling the internal parts of the Earth. And still it won't stay put. Some of the air is yet on the surface, and everyone can still breathe, although it's becoming much harder. Turns out, to fill the pit with air, we'd need to dig so much that the Earth would just fall apart before we finish. But even now, the enormous hole we've made has changed the planet's center of mass, and is now spinning and revolving around the Sun more slowly and awkwardly. Instead of pushing all the air from the atmosphere down below, we've caused a cataclysm that would destroy our planet much more quickly than the lack of breathing air. Okay, so let's rewind then. We can't dig a hole in the ground because the air just won't fill it, but stubbornly spills out, and eventually our planet will just be torn apart. And we probably can't dig through the ocean's bottom because the hole will get filled with water instead, and the air won't have the room either. And that's not saying anything about all the water that gushes down to the hot layers of the Earth, causing catastrophic reactions that will, you guessed it, blow the world to pieces. If so much cold water reaches the extremely heated depths of the planet, hot magma below will start releasing toxic gases into the atmosphere, suffocating any life on the surface. Oh boy. So, the only chance to fill the hole in the ground we made is to compress the air to a liquid state, almost like they do with scuba gear. The oxygen tanks are filled with super compressed air that allows divers to breathe for a long time using just a small vessel. Now, we could just fill several 100,000 of such tanks with compressed air from the atmosphere and throw them all into the hole we've dug out. The pile will only be several hundred miles high, so technically it's not possible. Or we could invent a really huge tank for just this one purpose, pump all the air from the atmosphere in there, compress it as much as possible, and then dump it into the ground. Congrats! Mission accomplished! We've dug a hole deep and wide enough so that all the air around the Earth fits inside it. Now, what happens next is all life on the planet stops breathing. Humans, animals, plants, even aerobic microbes can't survive without oxygen. So everyone and everything is effectively wiped out. Then, no more oxygen means no ozone layer either. The lack of this natural barrier makes the planet extremely vulnerable to the sun's radiation and cosmic rays. The flares from the sun stop warming the Earth and begin scorching it instead. The surface of the planet rapidly becomes an arid wasteland, bombarded with heat and UV rays. Next goes tectonic activity. With the temperature outside spiking, volcanoes start erupting all around the world, making it a churning mass of hot lava. Oceans boil and evaporate, mixing with toxic fumes and creating a thick blanket of black clouds. Ash and acid fall from the sky, covering the already scarred Earth. And finally, our former blue and green planet turns into a twin sister of Venus, the unbearably hot and inhospitable place where no life is possible. Well, this would not be a smart thing to do. So please, let's not try this at home. You want a super big hole? Try the Grand Canyon.
You're sitting at a coffee shop on Mars, keeping your head down, trying not to draw any attention to yourself. It's crowded, and many people are singing, dancing, and talking loudly about life on Mars. Your drink arrives, and you sip on it. So far, no one recognizes you. You're wearing a cloak with a large hoodie to cover your face and disguise yourself from everyone. Someone accidentally bumps into you and sees your face. The music stops, and now everyone is staring at you. You have nowhere to hide or run. You ignore the leering eyes and keep sipping on your beverage. An old bearded man sits in front of you, amazed to be in your presence.
"So, it's true. No one believed you'd make it," he says.
You don't reply and continue with your drink. Everyone else gathers around you. Another man speaks.
"Well, are you not going to tell us how you escaped from the clutches of the Space Kraken?"
Everyone gasps in shock. No one has ever made it to tell the tale of the Kraken, except you. Your plan was to find your messenger to take you to a spaceship far away from this planet. But it's too late, now that everyone knows you're here. And the messenger fled, knowing all the attention was on you. You lay back your hoodie and explain what happened. 2 days ago. You're in your full gear, ready to make the voyage into deep space. You have a solo ship that's designed to maneuver through all the obstacles in space. You prepare the rest of the gear and fuel up. Everyone is watching you, knowing that you might not make it back. But the Kraken has been floating in space for too long, disrupting shipping containers bringing in goods. A small ship like yours can sneak past its acute sense of smell and vision. But larger ships will get destroyed. You made it your mission to find this Kraken and study it. If you learn its ways and patterns, you can figure out how to get rid of it. Everyone says their goodbyes, and you lift off. You know that it'll be a very long way to get there, possibly 3 days in the emptiness of space. You saw some quick footage of it, but no one knows exactly where it sleeps, or if it even does sleep. You put on some tunes and set your ship for cruise control. You make some notes and set the camera to document yourself while you prepare everything you need. You also have some cameras outside recording everything that moves, even thermal sensors to catch living creatures floating in space. After a few hours, you exit the safe quarters of Mars and enter into the hostile territory. There is no place to hide or anyone to help you. A few little ships like yours pass by now and then. They watch you going further to the Kraken. You notice many floating signs powered by machines warning you about the Kraken. The cameras start recording, and you begin your video journal, which is transmitting to your network at home. So far, nothing. It's quiet and dark. Hours pass, and you're just floating in the middle of nowhere. You almost feel like you want to turn around, but then you pick up something in the sensors. You see a large live object nearby. You turn off the lights and slow down your ship. You resume recording and start talking to yourself, explaining everything. The object is getting closer and closer. You move aside to avoid it and latch on to a floating rock, but you still don't see anything. Out of nowhere, you see some glowing jellyfish-like creatures flowing together in a cluster. On your thermal sensors, they appear to be large objects, but in fact, they are just little creatures. According to your studies, these creatures are some of the main foods for the Kraken, so they're probably running away from it. After a few minutes, the creatures float away, and you launch yourself out and turn the lights back on. A few more hours pass, and you still see no Kraken. Suddenly, a whoosh shakes your ship, and you're thrown slightly off course. You notice that a large object has spiked your thermal sensors and left. You keep going and check the playback settings to see if your cameras manage to catch something. You try to look carefully, but it seems like a gust of wind blew past you, which is weird because there is no wind in space. You check the thermal sensors and notice that a large object shaped like the Kraken has zipped past you. It's still around, and it has probably caught your scent. Your system's got some DNA particles and are studying them. After a while, they show that the Kraken's skin can change colors according to its surrounding. Its skin is thick and made up of some cosmic fluorescent material that is new to any creature you've ever come across. The system continues studying it. After a while, the Kraken goes off your radar and disappears. You circle back, trying to find it. People back on Mars can see the data and already have information about its size and skin quality. They even see some footage you've managed to catch. As you continue driving towards it, you open your floodlights, trying to see anything. Your cameras are still rolling. Suddenly, the Kraken changes skin color and appears right in front of you. Its large tentacles flash around, whipping nearby space debris. Its large eye that's as big as a bus looks right at you. It opens its mouth, and you see layers of sharp teeth circling like a grinder. It has a large beak that can break your ship easily. It starts flashing its colors rapidly as a way to warn you. It shoots out some liquid to move in a no-gravity space environment. It's moving towards you until it launches itself. Your ship has an auto force field for protection, but it can't sustain the powerful bite of the Kraken. After only a few seconds, the shield breaks, and your ship spirals down to another planet. You crash landed in a swampy land. Your ship has survived, but it can't take off. The analysis of the Kraken is ready. It shows that it doesn't need oxygen to breathe, and its DNA is evolving. Now that it got a bite of your force field, it can adapt itself to create a bioforce field of a similar nature. But you crashed on a planet that is foreign to you. You put on your safety suit and observe the environment. The atmosphere is filled with nitrogen and sulfur. You get out and walk around. It has similar gravity to that of Earth. As you venture through the swamp, you start seeing little skin particles similar to those your ship has caught. The liquid below you is some foreign substance that seems to be deteriorating your suit, so you opt to hover. The trees are strange and seem to be living off the atmosphere, but there is no sign of life anywhere. Suddenly, you see a huge crater that leads to the center of the planet. You enter it and see some ships similar to yours. It seems that the Kraken knocked them off course, and they all crash-landed on this planet. Many of them seem to be intact, while others are completely obliterated. Your sensors pick up another reading. It senses another creature dwelling in the center. You try to get closer. You're doing your best to be as gentle as possible, but you feel the ground shaking below you. You duck down and try to avoid the rocks falling overhead. A large tentacle pops out of nowhere, and then another and another. It swings itself out and crawls in the open. According to your system's studies, this Kraken is 10 times larger and even looks different. It doesn't spot you, but it can sense that you're around. It starts thrashing the planet, trying to find you. It knocks your ship. You try to find a way to start it, but it's missing a piece. You find another abandoned ship and take out the part that you need and put it on your ship. Your suit has an auto repair function that allows you to fix your ship without the tools. After a few minutes, it's ready for takeoff. You power up your ship, even though it's damaged, and lift off. You manage to sneak past the Kraken. Everyone at the coffee shop is silent. Many don't believe your stories. They had stopped receiving live transmissions before you were knocked off by the Space Kraken. Out of nowhere, an alarm rings and warns that the Kraken has arrived. Everyone rushes off in a panic. You hear a voice in your head. It's a bunch of gibberish, but you start getting visions of the Kraken talking to you. It knows you're here, and it's coming for you.
Joseph Walker is about to have an historic flight, but he does not know of it yet. He smiles at his chase pilot, showing the OK sign, and closes the cockpit of his steel friend, the newest unpowered rocket plane, X-15. It's placed under the wing of a B-52 bomber. They take off and go up to 45,000 feet. Joseph is calm and full of joy because he has been getting ready for this moment his whole life. He trusts his steel-winged friend like no other. The bomber drops the X-15. The rockets fire up, and with a fantastic thrust, Joe flies steeply toward the edge of space. He knows his dream of making the first ever suborbital plane flight will soon come true. Joe adjusts the controls to intensify the rocket energy. In contrast to the usual blue sky plane view, the beautiful curved planet Earth view and a black horizon is a visual privilege only a few people can have. Joseph Walker's reaction shows he is experiencing zero gravity. "Welcome to space," the pilot says quietly. "We did it, guys." The Walker surname has always automatically propelled him to action. He just had to go forward, strive for higher results, and not stop. As a teenager, he loved to run, arms outstretched at the sides. He imagined that his legs lifted off the ground suddenly, and he felt himself flying, soaring up both as a man and an airplane. When he worked as a test pilot, he used to fly over city lights at dusk. They assembled themselves into gigantic mosaics below and reminded him of faraway stars he wanted to reach. His dream of becoming an astronaut and getting the astronaut wings, which he considered a great honor, was born at that time. On his way to his dream, Joe studied a lot and got a bachelor's degree in physics. He also had extensive test experience in the early X-series aircraft and 27 flights in rocket aircraft after joining the NACA, which stands for the National Advisory Committee for Aeronautics, in Dryden in 1951. He combined the experience with sound engineering judgment. What drives a test pilot to risk his life every day? Courage, duty, devotion, passion? All of it. Joe was a talented test pilot and would not have traded jobs with anyone, but he had always aimed higher. So he became the right person for the X-15 spaceflight program when he was invited to be its chief pilot. The whole team, including the engineers and all the 12 test pilots, had to prove that they could design an airplane that would fly and survive at hypersonic speeds. Before, there was only a theory about hypersonic flight and subscale wind tunnel testing. That's why there were many questions like, will they be able to prove it? Will they manage to design an airplane that will be stable and controllable at hypersonic speeds? Could they possibly create a structure that would survive the high heating rates associated with hypersonic speeds? And, more importantly, could a pilot survive and function adequately in this high-energy environment? When the X-15 launches from the bomber's wing, it first goes into a free fall for several seconds, and only after that the rockets can be ignited. So there was a considerable risk of a rocket failure too. The team also had to design an airplane that would be controllable outside the atmosphere and could successfully re-enter it at high speed and steep entry angles. If the X-15 took the wrong angle, the plane would be destroyed. So could they prove all of this? To regularly tempt fate is a real job of any test pilot. Joseph knew the anatomy of his winged friend as much as his own because his life depended on it. The X-15 looked like a big propellant tank with a cockpit. It was 50 feet long, 20 feet wide, and 13 feet high. But the propellant tanks took up approximately 25 of those 50 feet. The X-15 weighed 15,000 pounds without propellants and 33,000 pounds loaded with them. The propellants consisted of liquid oxygen and anhydrous ammonia. To fly at the hypersound speed of Mach 6 or 4,000 miles per hour, one must have an airplane that will survive temperatures as high as 1,200 degrees Fahrenheit. That's why the X-15 was built of steel Iconal X, a tough, high-strength nickel-steel alloy. Only 3 aircraft were built. The X-15 was by far the fastest plane existing at that time. It could fly at a speed of up to 7 times the speed of sound, which is 4,520 miles per hour. Joseph Walker could fly to the edge of space and land again within 12 minutes. The plane was powered by a liquid rocket engine, Reaction Motors XLR-99, which delivered a powerful thrust of 57,000 pounds. During Walker's first X-15 flight, he was unaware of how much power the rocket motors had, and he was slammed into the pilot seat yelling, "Oh wow!" The enormous ejection seat weighed 270 pounds. It had 2 large stabilizing fins deployed after ejection and 2 large telescopic booms that extended for seat stabilization. The aircraft had a conventional wing, although small, with only a 22-foot span and roughly 200 square feet of area. The aircraft's tail was unusual, with 2 canted horizontal and 2 vertical surfaces. These tail surfaces resembled the feathers on an arrow. They served the same purpose, keeping the aircraft stable and pointed in the right direction. The upper and lower vertical tail surfaces were pretty large and thick compared to conventional airplanes. They were wedge-shaped in cross-section with a sharp edge in front and a broad base at the rear. This provided additional stability and prevented the aircraft from swapping ends at extremely high speeds. The airflow sensor on the airplane's nose determined the airflow direction and impact pressure. This sensor was referred to as the ball nose. It was servo-driven to align with the airflow affecting the aircraft's nose. From this, the engineers obtained the angle of attack, the side slip inclination, and the impact pressure of the air flowing over the aircraft. The ball nose was cooled with liquid nitrogen to prevent it from melting during high-speed flight. Walker sometimes liked to playfully bet with his fellow test pilots who would be the first to lift the rocket plane above the Kármán line, the internationally accepted boundary of 62 miles. On August 22, 1963, during Flight 91, Joseph Walker sets a world record of the highest altitude of 67.08 miles reached by an unpowered plane X-15. The X-15 is hoisted up to the pylon on the B-52 wing. The hoists are located in the X-15 servicing, fueling, and mating areas. All pre-flight checks are completed. Takeoff. The X-15 is the first aircraft to utilize an inertial platform and a computer. Standard barometric instruments are almost useless in the X-15. Joseph has them on the instrument panel, but he only uses them during landing because they don't work at high altitudes or outside the atmosphere. For a sizable portion of the flight, he uses inertial data for control and guidance. Launch. The X-15 drops away from the bomber and gets into a freefall for several seconds. Then the rockets start by burning within 85 seconds, producing extreme power. Joseph pulls the plane up at a steep climb-out angle to start forming a long parabola and comes out of the atmosphere. The pilot has good visibility since the windows are next to his head. One very unusual thing about the visibility out of the X-15's windows is that the pilot cannot see any part of the airplane. He cannot see the nose, he cannot see the wings. Nothing. Typically, pilots use the nose and the wings in an aircraft for attitude reference. In the X-15, all Joseph has for a reference is the window frame, which is very disorienting on the one hand. But on the bright side, such a panoramic view is just right to enjoy the splendid horizon, a boundary between Earth and space. Joseph thinks how quiet it is here, like nowhere else. Mission completed. Joseph completes a perfect parabola and re-enters the atmosphere successfully. The X-15 is like a tough old bird that pops and bangs as it accelerates above extreme speed. But it all hangs together and gets Joseph Walker back home. He is ready to start a glide, landing from space. The X-15 has some outstanding features that significantly enhance the safety of landing. It has highly effective speed brakes, which are essential in an unpowered aircraft to adjust energy and ensure a pilot gets back to the ground safely. The more effective they are, the more precise the control of the power and the more accurate the landing. It's hard to imagine, but the pilot lands the X-15 only about 11 minutes and 8 seconds after its launch, having gone through the distance of 337 miles. Joseph Walker makes history as the first civilian test pilot flying to space by a rocket plane twice. Despite all the risks of the X-15 program, the courageous test pilots pushed the very limits of their piloting skills and physical health to master groundbreaking experimental technology. The program's overall success helped develop the Space Shuttle program and paved the way for NASA to continue to the moon decades later. Joseph Walker got a lot of awards and the cherished astronaut wings, but only many years later. The Lunar Landing Research Vehicle, used to develop piloting and operational techniques for lunar landings, was trusted to be piloted by Joseph, and the famous moon crater Walker was named in his honor. At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over, slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on 2 legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier, Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun, and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has two designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If two spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert.
There's a giant ghostly hand that stretches across space. Its eerie fingers are reaching for a glowing red cloud that looks like molten space lava. Although it looks like a scene straight out of a sci-fi movie, it's 100% real. The hand was formed after an enormous star collapsed in a huge supernova explosion. The boom created a new star that is bursting with energy. The energy given off by the star is so big that it caused debris from the explosion to swirl around it. This is what created the supernatural-looking hand. The hand is so big that it stretches a colossal 150 light-years. As for the lava-like structure it's reaching for, that's actually a huge gas cloud. So, while it looks spooky, it's completely harmless, and you can go to sleep tonight without worrying about a giant ghostly space hand scooping you out of bed. There's a bizarre star hidden in the depths of space that seems to randomly flash on and off. It's known as Tabby's star, and its light dims at super irregular intervals for really odd lengths of time. There have been so many theories about what's causing this, from meteor showers to outer space interference. The comet shower idea was quickly debunked. Dust from comets, which would block the light, goes away after a couple of months. Tabby's star fades slowly over decades, so the timing just doesn't add up. It can't be down to planets either, as no planet is big enough to block that much light from a star. After years of speculation, scientists have finally found an explanation for the strange phenomenon. The dimming and brightening are actually a result of space dust. A ring of dust surrounds the star, which often temporarily blocks its light. On day 8 of its mission in 2019, China's lunar rover discovered something really strange on the far side of our moon that caught the attention of the entire world. While navigating a path around a bunch of lunar craters, it spotted something really weird lurking inside one of the moon's holes. It was a colored substance, just like gel, that we'd never encountered before. The curious material was a rich dark green color and glistened like diamonds. After a year of analyzing the foreign substance that measured 20 inches by 6 inches, the scientists finally came to a conclusion. The glistening effect seems to come from glass. In space, it usually appears as a result of lunar impact melts. This means that it's most likely from a comet or rock that has hit the moon and melted upon impact. But while it's likely that the strange substance is just melted rock, scientists aren't 100% sure. This is because the pictures were captured under bad lighting conditions, and there were a bunch of other factors that badly impacted the quality of the images. So, the jury is still out on this one. There's a huge space cucumber floating through the galaxy, and no one really knows where it came from or why it's there. Okay, it's not exactly a cucumber, or a pickle. It's more likely a super elongated rock. Scientists think it may be longer than half a mile, but only 540 feet wide. It's traveling so quickly that there's no way it's bound by our sun's gravity, meaning that the strange object was formed somewhere outside of our solar system. We don't even know how long it's been wandering through space. It's estimated that it entered our solar system during the Victorian era, but who knows where it had traveled before then. For years, we've been told there are 8 planets in our solar system. 9 if you count Pluto, which got kicked out of the club some years ago. But that might all be about to change. There may be an enormous secret world lurking in the midst of our system, which scientists are calling Planet 9. This undiscovered planet could be way out past Neptune. There are seemingly unexplained clusters of orbits there, and this hidden 9th planet would explain this. The planet, if it exists, would be 10 times the size of Earth, take at least 10,000 years to orbit the Sun, and would sit over 200 times further out than our home planet. This is why it's been so tricky to identify, as it's almost impossible to take a picture of. In 2019, 30% of the area that the planet is likely to be in had been searched. It will take at least another 2 years to cover the remaining area. In the meantime, we'll be waiting on the edge of our seats. No. Strange radio waves are beaming down on Earth, and scientists are baffled. These fast radio bursts are sudden, unexplained, and last just milliseconds. We first picked up the weird signals in 2007, and scientists have been scratching their heads ever since. They appear to be coming from outside the Milky Way, millions of light years away. For us to pick them up from that far away, they must be emitting more energy in a fraction of a second than the Sun does in 80 years. Most of these signals only came once, which would have made identifying them much easier, until this all changed in 2017. In August, a signal was picked up that repeated 93 times, ruling out speculation that the signals were being caused by random one-off events. To this day, we still don't know what's causing the signals. Back in 2014, NASA captured a surprising picture of the Sun that showed that it might like to play dress-up. A brilliant storm of magnetic fields caused the Sun to look like a flaming jack-o'-lantern. Even weirder is that the image was captured on October 8th. It was possible because of something called active regions. These are basically areas of the Sun that have greater levels of light and energy. This is what gives the flaming look in the images. The light forms 2 eyes, a nose, and a wide, jagged, smiling mouth. Fortunately, this look was just a coincidence, and there isn't a giant pumpkin carving enthusiast lurking in the depths of space. Hey, I want to know, is this a trick or treat? Space fans spotted what appeared to look like a spoon on the surface of Mars. It was half covered in dust. They noticed it after images from a Mars rover had been released. As spooky as the suspicious silverware may sound, it was just a trick of the light. The spoon is just a regular old rock, albeit in a slightly odd shape. The play of shadows in the photo made the object look even more spoon-like. Maybe there's a dish nearby that the spoon ran away with. A cosmic eyeball floating somewhere among the stars is no regular-sized eye. It measures an incredible 660 miles across. One of Saturn's moons, Tethys, has become a bit of a celeb to space fans. The spherical moon sports a large crater that makes it look exactly like a giant interplanetary eyeball. There's even a set of peaks inside the crater that look like an iris. Saturn has a gang of 60 moons in total, and Tethys isn't the only one that looks like a random Earth object. Prometheus looks like a potato, Atlas resembles a pita bread freshly served from a Greek restaurant, and Mimas even looks like some villain's spacecraft. And then there's this. There's a giant cat's eye right in the middle of space. Its official name is NGC 6543, but that's kind of long and boring, so most people call it the Cat's Eye Nebula. And it's actually one of the first nebulas to have ever been discovered. Like other nebulas, it was formed by a star that shed its outer layer of gas. The gas floated off and produced this amazing and intriguing structure. The star fires off this layer of gas every 1,500 years. Each time it does this, it creates a spectacular new dust shell. Hey, don't get me started on gas.